Hello mga ka-wisdom! Welcome to Wisdom is Power channel. Kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos like this. Thank you! Today we're going to talk about the voltage regulation of transmission lines. Voltage regulation of a transmission line refers to the ability of the line to maintain a stable voltage level under varying load conditions. It is the ratio of the difference between sending and receiving end voltage to receiving end voltage of a transmission line between conditions of no load and full load. It is expressed in percent. So sa voltage regulation, kailangan ma-maintain natin yung value ng voltage ng sending end voltage natin ng transmission line doon sa voltage sa receiving end voltage ng ating transmission line. So, mathematically, yung ating voltage regulation ay pwede nating express using our equation. The voltage regulation is equals to the sending end voltage minus the receiving end voltage all over the receiving end voltage multiplied by 100%. So, ito ang ating equation na gagamitin to calculate the percentage voltage regulation. Itong expression na to, it means a lower percentage voltage regulation is better for the performance of a transmission line as it indicates more stable voltage level even with changing load. So, mas mababa yung percentage ng voltage regulation natin, mas maganda kasi nagpapakita ito ng mas mababang losses sa buong transmission line natin. So, kung mag-i-equal yung sending end voltage natin dun sa receiving end voltage natin, so mas maganda. So hindi naman nangyayari yun, ano? So, meron tayong na-experience na voltage drop along the way ng ating buong transmission line. So, yung voltage regulation natin, pwede rin nating express sa ibang book that the no load voltage minus the full load voltage all over the full load voltage times 100%. Kasi nga, at no load condition, yung ating sending end voltage ay equals dun sa receiving end voltage natin. Dapat sana. Kaso hindi nangyayari ngayon dahil may mga factors na nakakapekto sa performance ng transmission line natin. So ano-ano ba yung mga yon? Una, line impedance. So the resistance and reactance of the transmission line affect how voltage drop occurs as current flows through the line. So, tumataas ang impedances natin. So, naapektuhan ang voltage regulation natin. The load characteristics, tulad ng kung siya ay inductive, capacitive, or resistive, will influence the voltage drop differently due to their power factor. The line length. The longer transmission lines typically exhibit greater voltage drops due to increased impedance. So, these are the factors affecting the voltage regulation of the transmission line. So let's have practice problem number 1. So a 50-kilometer transmission line with line resistance of 0.2 ohm per kilometer and a line reactance of 0.1 ohms per kilometer. Calculate the voltage regulation of the transmission line if the sending end voltage is 11 kilovolts at 0.8 lagging power factor and the load power is 500 kilowatts. So, having this problem, we can write all the given first. The resistance is 0.2 ohms per kilometer. The reactance is equals to 0.1 ohms per kilometer. The sending end voltage is 11 kilovolts. The power factor or the cosine phi at the receiving end is 0.8 lagging power factor, while the power or the load power is 500 kilowatts. And we are asked to solve for the percentage voltage regulation. So, solving for the total resistance first, we will multiply it by the total length of the transmission line by 50 kilometers. So, we will get 10 ohms. The same thing with the reactance, we will multiply it by 50 kilometers and we will get the 5 ohms. So, meaning the impedance is simply 10 plus J5 ohms in complex form. Then, let us solve for the apparent power. Then this will give us 625 kVA, and this will allow us to solve for the line current, that is apparent power all over the square root of 3 multiplied by the line voltage. This will give us 32.8 amperes. Then, to solve for the receiving end voltage, since the given is the sending end voltage, we can now solve for the receiving end voltage. I-manipulate lang natin yung equation. Then the equation will be the receiving end voltage is equals to sending end voltage minus the product of current and our impedance in complex form. So substituting all the values to our equation, this will give us 10.64 kilovolts for the receiving end voltage. Now we have the value of the sending end voltage and the receiving end voltage. Then we can solve our voltage regulation. So 11 kilovolts minus 10.64 kilovolts all over 10.64 kilovolts multiplied by 100%. This will give us a voltage regulation of 3.38%. Practice problem number 2. An overhead three-phase transmission line delivers 5 megawatts at 22 kilovolts at 0.8 power factor lagging. The resistance and reactance of each conductor is 4 ohms and 6 ohms respectively. So determine the percentage regulation. So again, let us write all the given first. And we are required to determine the percentage voltage regulation. So for our solution, so let us solve first the phase current, that is power all over 3 multiplied by the phase voltage multiplied by the cosine theta, or simply the power factor. Substitute but first we have to get the value of the phase voltage by dividing the line voltage by square root of 3. This will give us 12.701 kilovolts. So to get the phase current, substitute our equation, that is 5 megawatts all over 3 multiplied by the value of our phase voltage multiplied by the power factor, and that will give us 164.03 ampere. Then substitute our equation for the sending end voltage in complex form. Then this will give us 13.82 kilovolts per phase. So getting the value of the line-to-line voltage for the sending end voltage by multiplying it by square root of 3, this will give us 23.94 kilovolts. Now we have the value of the sending end voltage and the receiving end voltage. We can now solve for the voltage regulation by substituting all the values we compute. Then this will give us a voltage regulation of 8.82%. So let's have practice problem number 3. A three-phase transmission line, 10 kilometers long, delivers a load of 5 megawatts at 11 kilovolts and 0.8 power factor lagging at the receiving end. The resistance of the line per kilometer per phase is 0.1 ohms, and the reactance per phase per kilometer is 0.2 ohms. Calculate the voltage regulation of the line. So again, we will write all the given first. Then we are required to calculate the voltage regulation of the line. So first we need to solve for the total resistance by multiplying it by the length. So this will give us 1 ohms, while the reactance will give us 2 ohms. So the total impedance will be 1 plus J2 ohms in complex form. So solving for the phase current, that will give us 5 megawatts all over 3 multiplied by the phase voltage. So the phase voltage, makukuha natin yon, yung line voltage, divide lang natin ang square root of 3 multiply again by the power factor of 0.8, and this will give us 328.04 amperes. Then substitute to our equation for the sending end voltage in complex form. So remember, our receiving end voltage should express in phase voltage. So i-divide natin ng square root of 3 yung ating receiving end. So that will give us a per phase value of 7.014 kilovolts for the sending end voltage. Then, ibabalik natin, para makuha natin yung line-to-line voltage, multiply natin ng square root of 3, that will be 12.15 kilovolts. Now, we have already the value of sending end voltage and also the receiving end voltage. Isa-substitute na lang natin yung mga values na yon doon sa ating equation. Then, this will give us a voltage regulation of 10.45%. So, that's all mga ka-wisdom. Again, kung bago ka pa lang sa channel na ito, huwag kalimutang mag-subscribe, i-like, mag-comment, at i-share ang video ito. Click mo na rin ang notification bell to receive more wisdom videos like this. Salamat!